Okay, today we're going to be talking about families of right triangles, and these are basically important groups of Pythagorean triples that we can use to help us solve for the missing sides of right triangles a lot faster. So before we actually get into the Pythagorean triples themselves, I want you to pause the video for a moment and use the Pythagorean theorem to solve for x for these three right triangles. Okay, so you should have gotten x equals 5 for the first one, x equals 8 for the second one, and x equals 12 root 3 for the third one. So let's see what patterns we notice here. So I have the sides written on top of each triangle. So let's just look at the first two. We have a 3, 4, 5 and a 6, 8, 10. So comparing these two, we might notice that if you just multiply the first group by 2, you get the second group. Okay, so if we just took everything in here and multiplied it by 2, that will give us our 6, 8, 10. So this is just a multiple of 3, 4, 5. Now let's look at this last group. We have 9 root 3, 12 root 3, and 15 root 3. So if we compare this one again with our first group, 3, 4, 5, we can see that it's just 3, 4, 5 times 3 root 3. Okay, so we have our 3, 4, 5 times 3 root 3, which will give us 9 root 3, 12 root 3, and 15 root 3. Alright, so moving on, what pattern do you notice? Well, we notice that each of these is just a multiple of 3, 4, and 5. Okay, and so 3, 4, 5 is going to be our first Pythagorean triple, our first family that we're going to look at. So there's a lot of Pythagorean triples, and there's a few that you need to memorize. So the ones you need to memorize are 3, 4, 5, which we've already talked about, 5, 12, 13, 7, 24, 25, and 8, 15, 17. Alright, so these ones are the most common. These ones you for sure need to memorize because that will help you use them really quickly to solve problems. So a couple other ones that are good to know are 9, 40, 41, 11, 60, 61, maybe 12, 35, 37. Those you don't actually have to memorize necessarily, but they might come up, so if you're familiar with them, it'll be easier for you to recognize them. Alright, so let's see how we can actually use these to solve for x. So rather than doing the Pythagorean theorem, we're going to use our triples. So looking at the first one here, this one's pretty clear. We can see we have 7 over 2, 25 over 2, which lets us know that our x is going to be 24 because that's 7, 24, 25 family. And then to make it match the other ones, it's going to be divided by 2, which simplifies to 12. Alright, and then our next one. So we have 16 and 30, and then our hypotenuse is x. So let's first think of a common factor between 30 and 16. So if we divide 30 and 16 each by 2, we get 15 times 2 equals 30. 8 times 2 equals 16. So now we can recognize our family, 8, 15, and then 17 times 2 gives us x, which equals 34. Alright, and then our last one here, we have 9, 12. Our hypotenuse is x. Again, we'll look for a common factor. So this one is 3. So we have 3 times 3 gives us 9. 4 times 3 gives us 12. And then 5 times 3 is finishing our family, 3, 4, 5, which will give us x equals 15. Okay? So now I want you to try the next 7 problems on your own, and then we will talk about the answers. Okay, so our first one, you should have got x equals 0.5 using our 5, 12, 13 triangle. Our next one is x equals 25. And then we have x equals 26. Number 4, x equals 50. Number 5, we have x equals 2400. And number 6, we have x equals 34 root 2. And then number 7, we have x equals 8 root 2. So here on number 7, we had to simplify our radicals in order to find our Pythagorean triple of 3, 4, 5. So it's 3, 4, 5 times 2 root 2, which gave us 8 root 2 for x. Alright, last one we're going to do together. So this says find the diagonals of a rectangle whose sides are 20 and 48. So first we'll draw our rectangle diagonal, so we know this is a right triangle here. Sides are 20 and 48. Instead of using the Pythagorean theorem, obviously we're going to try to use our triples. So a common factor between 48 and 20 is 4. So we know that 20 divided by 4 equals 5. 48 divided by 4 equals 12. So our triangle is 5, 12, and then our hypotenuse is going to be 13. But we need to multiply it by 4. So that will give us our diagonal length of 52. If x equals 52. Alright, and then number 9, I want you to try on your own. You're going to try to find QD using Pythagorean triples. Do not use the Pythagorean theorem, so use our triples and the multiples of triples to find QD. And if we have any questions, we can talk about it in class.